and a very good evening to this Japanese Professor Tsuchikawa and others who were present in this meeting. So it's actually our great pleasure that we are organizing the first webinar today. This is actually a pre-conference webinar that we planned mainly because we are going to organize this Asian NIR Symposium in Kolkata in 2024. This will be held from December 8th to 10th next year. And before that, since this is going to be the first big international conference on NIR spectroscopy in India, so we thought that it would be better if we can have some webinar series. Every month we'll have one webinar. So this is the first webinar, and today we are really delighted to have Professor Tsuchikawa. He's the main motivator for us, for our Indian team. He came here in 2019, and he invited me also to their conference in Japan. So we are really very honored and delighted to get Professor Tsuchikawa in the kickoff meeting of our webinar series. So we'll have 12 such webinars in the next year, and after that we'll have the ANS conference. Now, Professor Tsuchikawa will talk about this ANC because he's holding a very important position in Asian Near-Infrared Consortium, and he's holding many other positions that I'll talk about, and also on the R&D on NIR spectroscopy in Japan. So he'll talk about nearly for 40 minutes after I give a short introduction about Professor Tsuchikawa. Professor Tsuchikawa at present is the Dean at Graduate School of Bioagricultural Sciences at Nagoya University. And he is basically a person from agricultural sciences, graduation and post-graduation, and PhD, everything from Nagoya University. He is a professor at the Graduate School of Bioagricultural Sciences in Nagoya University since 2004. And he was the Vice Dean from 2016 to 2018. And now he's the Dean from 2019. And he is holding very important positions on NIR spectroscopy all over the world. He is the president of the Asian Association of Agricultural Colleges and Universities, AAACU, from 2022 to 2024. He is the president of the Japan Wood Research Society, 2021 to 2023. He is the president of Asian NIR Consortium, ANC, from 2018 and still the president. He is the president of the Japan Council of Near-Infrared Spectroscopy from 2016 to 2020. And he's also is a member of the management committee in the International Council for Near-Infrared Spectroscopy from 2019 to 2025. They organized one big conference recently in Austria. And to his credit, there's many awards. In 1996, Professor Tsuchikawa received the NIR Advance Award from Japanese Society for Food Science and Technology. In 2003, Forest Development Technological Award from Forest Development Technological Institute of Japan. Then from many awards from different industries. In 2003, from Parkin-Elmer, the organizing committee of NIR 2003. From Buchi, NIR Award from Buchi. In 2004, the award of Japan Wood Research Society. In 2017, the Shield of an Honor Award from Kasetsart University, Thailand. In 2017, Thomas Hirschfeld Award from the International Council of Near-Infrared Spectroscopy. 2018, the Gerald S. Barth Award once again from the Council of Near-Infrared Spectroscopy. So with this short introduction, you can understand he's really a pioneer in the field of near-infrared spectroscopy, and we are really thankful to him for giving us the support to organize. He is the main motivator for our next year event, and this event is going to be the first in India on ANIC. This is a biennial event. First time it will be held in India. So with that short introduction, may I request Professor Tsuchikawa to please tell us about this ANC and how you have been with ANC and your research experience on agriculture and forestry. Yeah, Professor Tsuchikawa, please.
Thank you so much for the Professor Pandyapadai for the very, very kind and polite introduction for me. And very good afternoon, everybody. I'm Satoru Tsuchikawa. I'm a graduate school of the Bioagricultural Sciences in the Nagoya University in Japan. It's a very, very good opportunity for me to give such a very nice experience to introduce my experience and to inform in the status of the Asian NIR Infrared Consortium. So today's my kickoff meeting webinar title is Asian NIR Infrared Consortium and RD on NIR spectroscopy in Japan, especially in the area of agriculture and food forestry. Yep. Okay. Now is the PowerPoint is safely changed. Okay.
Yeah.
Okay. Actually, I don't know. Today the participant, now I can calculate over the 60 participants can join this webinar. Thank you so much again. And anyway, I guess, so the participant may be interesting in the potential and the applicability of the NIR spectroscopies. Later, I will shortly explain in the powerful situation of the NIR spectroscopies. Anyway, this ranging from the 800 to the 2500 nanometer, this NIR range is very, very powerful as a non-destructive measurement of the organic material, agriculture product or food, and especially in the forest product. So non-destructive measurement of agriculture product using NIR spectroscopy should be an interesting approach. This photograph shows the great potential in all phases of the material assessment. For instance, in the polymer, textile, pharmacy, petrochemical, and etc., etc. Oh, I know. Now is the Indian country has the growing very, very dramatically. Many people, many scientists, many companies, and university institute are so interesting into utilize of the NIR spectroscopies, also the various areas. This photograph is a very, very memorial photograph because the Dr. Carl Norris, he unfortunately passed away is 3 or 4 years ago. He was the very, very elder age, 1905 or 1906. He was founder of the NIR spectroscopies, and he was the researcher in the USDA in the United States of America. And this device is the first NIR instrument used by the Dr. Carl Norris. Very, very primitive and very, very basic spectral photometer he designed. And in case of the Japan, in the beginning of the 1980s, so this means almost the 45 years ago, NIR spectroscopy has been introduced from the USA on the basis of the big knowledge, big contribution in the Dr. Carl Norris. And you can find some of the researchers. They are the famous researcher in the Japan, in the Professor Iwamoto, Professor Matoba, Professor Ozaki, Professor Kawano, and Professor Takayanagi. They are the former chairperson in the Japan NIR Consortium. Now is the chairperson is the Professor Takayanagi. And before the Professor Takayanagi, I was the chairperson in the Japan NIR Consortium. Oh, now, this is also the historical photograph. from the 1985, the Symposium on Non-Destructive Measurement, including NIR spectroscopies, was held every year by the Japanese Society for the Food Science and Technologies. So you can understand in the how to say, in the origin and the basic concept is coming from the applications of the food or the agriculture in the area of the near-infrared spectroscopy in Japan. So, 1989, second ICNIRS was held at Tsukuba, Japan. It was also the very, very memorial photograph. And center logo, this is the actual logo of the ICNIRS. Oh, this is our Japanese NIR researcher is so proud of. This logo was contributed in the use in the ICNIRS. And fortunately, in the 4 years later, 2027, we can invite in again the international NIR conference in the Nagoya. So I deeply welcome for all of the participants to join the international conference in the Nagoya 4 years later, 2027. And anyway, such as the Japan Council of NIR Spectroscopy was founded again in the 2004, and from the 2005, JCNIRs organize the NIR forum every year. Actually, we already invited in the Professor Pandupadai as the guest speakers in this very, very exciting symposium. And now, JCNIRS, Japan Council of NIR Spectroscopies, organize the NIR forum every year, I told to you. And furthermore, we try to organize in the Asian NIR Symposium every other year from the 2008. This left logo is the JCNIRS, and right logo is the Asian NIR Consortium. Oh, sorry. And this photograph also shows the birth of the Asian NIR Consortium. In order to expand NIR spectroscopy to the Asian countries, ANC was constituted among China, Japan, Korea, and Thailand when the Japan-Korea Joint Symposium on NIR Spectroscopy was held in the 2006 in the Seoul. It's almost 70 or 18 years ago. In that time, Indian NIR researchers could not join. However, in the later, Indian researchers also joined these societies. And this photograph shows in the NIR Asia NIR Symposium 2018 in Kunming, China. You can find so many people joined this conference because this is a joint symposium in the NIR Symposium and the 7th Chinese National NIR Symposium. I remember in this case, total in the participant over 300. And then later, in the ANS 2020 was held in the Konkan in the Thailand. Fortunately, we can safely in the organize this symposium before the COVID-19. Quickly, COVID-19 was happened very quickly. So in the last year, ANS 2022 was held at Seoul, but in this case, only as an online symposium. So anyway, for me, in the personal memory is it was the first time for me to meet the Professor Pandupadai or the Mr. Ajant and Ajant Hazarika and another Indian colleague. And in this time, we frankly discussed the possibility to arrangement of some kind of the NIR symposium of the seminar in India. So next year, Professor Pandupadai has a big effort. He tried to organize in this international workshops, application of NIR spectroscopy in food and agriculture in the 2019. It was also very, very successful symposiums. Fortunately, I also can join this symposium. This is a final in the group photo. You can understand so many scientists in the participant is enjoy very much in such a very nice symposium in the India, in the Kolkata. So he also tried to invite the Asian NIR symposium in the next year, 2024. I think it should be a very, very successful. Okay, I back to the basic concept of the NIR research. Maybe you can sometimes find such as NIR spectroscopies. It is including the absorption band of the functional groups of OH, NH, and CH. So this means such as a very, very unique NIR spectra included so many kinds of the functional in the chemical information in the food or the agriculture as well as in the wood product. And I will show some of the potential of the NIR system, especially the online NIR systems in the Japan. First example in this Wakayama area. This area is very, very famous area in the two producted orange. So you can find let me see, one short movies. Sorry, a little bit noisy. And you can find many, the orange is running in the belt conveyor. And you can find the white box. In the white box include the NIR devices by using the NIR devices in the another white box by checking the coloring in the size of the orange. Okay. So next example is the Nagano area. Nagano area is famous as a good production of good apples. Also, this area is already introduced such kind of the fruit sorting machine for this apple. Oh, sorry. Okay, you also can find in the apple is the running, and in this box is including an NIR devices. And by this sorting, fruit sorting factories, all of the apple can be detected in the sugar content, partially in the acidity, in the size of some of the defect in the inside. In the next is in the example of the melon. This Hokkaido island has the famous island to product the melon. And this is a very, very unique fruit sorting because in this case, in the melon is a so big size. So this fruit sorting factories uses a laser system as a light source. And now is the melon is running. And this white box is including the laser light, and the penetrate and the laser light could be detected in the sensing systems, and all of the melon maturity and the sugar content is evaluated with the high pressure situations. Okay. I hope you can estimate, the potential in the online measurement conditions by using the NIR right. And next, I'd like to briefly inform the routine NIR systems in Japan. This is the Okinawa Island. Okinawa Island, a small island, however, very, very active area to production in the sugar canes. Maybe I guess in the India, you also can product the sugar cane very much. And in the Okinawa Island, there are so many kinds of the island, and small island or the big islands, each island products in the sugar cane. However, the quality is very, very variable. oh, this area, how to say, to the management of the system to keep the good quality of the by the sugar content of the NIR spectroscopy. So for each island, each system is set up, and for each island, the researcher and engineer to check of the quality of the sugar cane. And this is some of the picture of the sugarcane factories in the Okinawa island. This is a very, very normal conditions. And probably some people know that how to make the sugar from the sugarcane. So how NIR is utilized in the sugarcane factory is when in the sugarcane is bringing in this factory, some ready is set up for to how to say to check of some of the sugarcane pattern, and some engineers try to sample preparation, steering, and packing in the cup, and he set up in this cup in the top of the NIR spectroscopies. So for each island, each factory should be set up in the same devices, and the same protocol is available to keep the good quality, and to keep, how to say, to set up for the same quality of the NIR data or something. And of course, in the food area, in such as the online grain quality control is a very, very normal situation in the Japan food factories. This is also one of the very, very typical example of the online measurement to making the butter. In the right is irradiated, and the reflected light is continuously detected, and continuously is analyzed in the NIR spectra, and the factory can check is the moisture content in the fat or some of the chemical component by using the NIR spectroscopies. So another trend to utilize in the NIR is to making the miniature size of the devices. You can imagine in such kind of the device is also very, very small. Very, very typical small devices is this one. This is made by the former company name is JDSU, established such a very small size of the NIR spectrum. And in this case, its power supply was coming from by throwing the USB cable. So not only the agriculture or the food items, by using such a small size devices, for instance, in the fat content in the fish could be measured in the very, very high accuracy situations. So again, I like to intense such kind of the small devices is a very, very high topic area to making the new NIR spectroscopies. And another trend is application to the medical science. You can find this Reddit is put on the very, very specialized caps. And actually, is NIR light is very easy to penetrate in the human bodies. So NIR light can very easy penetrate in the content is to check the absorption spectra of the hemoglobin situations. So by using such a devices, in the medical doctor can understand which area in the brain is much more active. Active area means the rich area is the blood. So medical doctor or another health making companies are very enthusiastic to introduce in the NIR for the hospital or the another conditions. So this is also the high topic in the NIR spectroscopies. So I like to back to my area is agriculture and the forestry. And maybe I'm not sure that how many people are interested in to utilize in the wood in the Indian society. And anyway, wood is the complex material. It's including for instance, in the cellulose, lignin, hemicellulose, and minor amorphous extractive. And cellular structure also is very, very complicated. However, we can get a much more useful information from such as wood material by using an NIR spectroscopies. This is a typical NIR spectra of the wood. This spectra including in the cellulose information, hemicellulose, lignin, extractive, and the water. And such as the data information overlapping each other. This means it is a very, very complicated, very difficult to understand in the each absorption conditions. But by the combination in this unique spectra and some other data science technologies, we can get the fine information from the NIR spectra. So I already informed in some of the ability of the NIR system for the online or the systems in the agriculture or the food items. How about the wood industries? Actually, our research group was constructed in the very, very basic online system to check in the wood qualities by using an NIR. Oh, this is one of the typical photograph. You can find the black box. In the black box is the imaging analysis. And this black box was, we designed a new NIR devices. And wood is running in this belt conveyor. In the finally,
मेरा सर
we
चल
could...
कहाँ रहा है सर फिर मेरा सर
Can I continuously the talking is okay now? Is I can find another voice? Is okay? Okay.
Yes sir, yes sir.
Okay,
Yeah,
okay.
You please continue. There was
Yeah. Okay, anyway, by using such as online systems, very easily to predict in the moisture content and the mechanical property of the wood. And another topic is application in the hyperspectral imaging. Maybe many people are so interested in to introduce a hyperspectral camera to check the quality of the food or the agriculture or the wood industries. It's a huge information on the each pixel informations. So this is the basic concept in the hyperspectral camera. In this case, basically in the such as the line scanning push broom system is a much more the normal measurement style. So in any way, by using this camera, for the each pixel include such as a very, very big information of the each NIR spectrum. By using a hyperspectral camera, for instance, for the one of the application is the wood industries, we try to check in the evaluation of the acceleration of the surface of the wood. Acceleration is a very, very useful engineering process for the wood systems to keep the good quality of the surface of the wood. However, very difficult to how much is acceleration is going or not on the surface of the wood. By checking and by investigating on the surface of the wood, we can very easily to check how much is the going of the accelerations by using a hyperspectral camera. In the upper side, it means the visible camera. By using the visible camera, we cannot understand how much is the acceleration is going. But just only pay attention to the 1727 nanometer. This absorption band means one of the CH band in the acetyl. So by pay attention to only the one wavelength absorption band, we can evaluate its variation in the acetations by using this camera. And this is the mapping of the strengness of the MOE. It's one of the factor of the mechanical factor of the wood veneer. Of course, you know, there are some of the knot or the cracks in the surface of the wood, but by checking of the NIR hyperspectral camera, we can evaluate it, which area is much more the stronger area or the weak area. I told to you in the NIR spectra, basically is the aggregated of the information of the chemical component. So in case of the wood, we try to evaluate is the mechanical property of the wood. Why the mechanical property could be detected by the NIR? The reason is very simple, because in the strongness area is the wood is included a much rich area in the cellulose, and the weakness area is so as a poor area is the cellulose. It's directly related to the chemical component of the cellulose, so we can understand is evaluate in the where is the strong area, where is the weakness area in the surface of the wood. And another point to utilize is the wood is a drying system is very, very important. You know, after the standing tree conditions, the wood includes so many, much of the moisture. However, to utilize, to investigate, to utilize the wood, it's very, very difficult to use it as is situations. So normally, in such as the perfectly dried condition is very, very preferable. But from the viewpoint of the industry, it's very difficult to control in the drying systems. So by using the NIR spectroscopy, it's also the one of the very, very, how to say, in the basic research, one of the basic research, by changing in the moisture content and to check in the surface of the wood, we can very easy to evaluate is that how the moisture is spread in the inside of the wood. So it is possible to change the drying temperatures, which is difficult to be achieved by the experimental studies. And one of the examinations, we try to visualize of the moisture content in the wood, in the some of the wood species. You can understand from the high moisture content to the low moisture content, very easy to visualize where is the rich area is the moisture, where is the poor area is the moisture. And not only the visualizing is the moisture content, where the combination in the principal component analysis, we try to the presence of the hydrogen bonding. How to say, this is a red area is a strongly hydrogen bonding area. In the blue area is the free water area. By the combinations in the real visualizations in the NIR camera, and by application is the principal component analysis, we are very successfully to the mapping of the hydrogen bonding conditions. Oh, this is one of the example is the mapping of the wood density and the microfibril angle. Microfibril angle also the one of the physical property of the wood. I don't like to explain much more the detail, but anyway, it's as how to say is the matching of the X-ray measurement. X-ray measurement is very, very powerful to the fine structure of the variation of the wood densities, and on the basis of the X-ray measurement, we try to, in the fluctuations in the densities of the X-ray and the NIR spectra, and the successfully NIR spectra is very, very easily to trace of the fluctuation of the density by the X-ray. Of course, you know, X-ray is a little bit dangerous. However, in the NIR spectroscopy, it is also safely magnetic wave range area, or if we enable to use the use of the NIR right by the instead of the X-ray, we can very easily to trace in the safely of the such as the fluctuation in the wood. And this is the example of the application in the NIR imaging analysis by using the fruits. This is the we cut of the apples and we try to the mapping of the sugar content by imaging analysis very, very easily successfully of the variation in the sugar content in the cutting apple. And this is also the one of the high resolution and non-destructive evaluation in the spatial distribution in the nitrate in the spinal ribs. You know, spinal ribs is include so rich nitrate. However, in the it's not so as a uniform variation in the same leaf. So by using the NIR hyperspectral camera, we can very easily to check which area is much more the high rich area in the nitrate by using an NIR spectroscopies. However, it's a big problem by apply of this imaging analysis because in the case of this cut apple and the wood and spinner and the leaf, everything is how to say in the very, very flat materials. But normally in the agriculture product is of course in the three-dimensional structures. For instance, in the mapping of the and the spreading of the sugar content in the fruit is very, very difficult by only a very, very simple measurement of the NIR imaging analysis. So in the such as the three-dimensional materials, we try to check observe the imaging NIR imaging by rotating the samples. In this case, this is one of the three-dimensional mapping of the sugar content of the kiwi fruits. It's a very, very unique, however, very, very successfully we get into the mapping of the sugar content or the pH by using the NIR imaging analysis. And this is also the application in the prediction images of the in this case, is the white strawberry. White strawberry is a little bit expensive strawberries, but very difficult to the how much sugar content all of the structures. Only the same applications we try to very successfully to apply all the variation in the sugar content in the each strawberries. And this violin plot it's represents the distribution in the pixel bricks values of the each ROI. This is one of the application of the violin plot. And we also try to geometrical influence correction of the apples by the checking of the early bruise detection. Early bruise detection is one of the defect area in the apples. So we mechanically we attacked in the apple. Of course, this area is the bruise and the much more the defect area. And we try to measure in the such as three-dimensional apples, not only the NIR hyperspectral image camera by using the laser profilometers, and finally we are successfully in the where is much more the defect area from the viewpoint of the three-dimensional structures. And this is my final research topics. It's the application of the data science of the by combination is the NIR spectroscopies in some kinds of the data analytical methodologies. So firstly, we try to by using the wood NIR and hyperspec camera and convolutional neural network to identify the wood species. This is some of the NIR data of the wood species. In this case, there's a real visible image of the wood. You can find in the 38 wood species. Basically, I'm the wood researcher. However, for me, very difficult to identify which wood species for such as 38 wood visible imaging. And this is the NIR image. How we could get the NIR image is the concept is very, very simple. By using the NIR camera, we measured in each wood species, and after that, we apply the PCA and analysis, and PC1 as the red, and the PC2 and the blue, and the PC3 and the green. It's as a how to say, it's a very, very such as the loading spectra could be as a changed, or the red color as the PC1, and the blue color and the PC2, and the green color and the PC3. And finally, in the mixture of the three colors, very, very colorful imaging comparing to the visible images. And on the basis of such as very, very colorful NIR imaging, we try to analyze and classify in the wood species. And so far, in the accuracy of the classifications in the over 90%. So in any way, in the combinations in the NIR hyperspectral imaging and deep learning is a good choice to recognize in the spatial distribution of the chemical content in the biological materials. Of course, in the India, it is a smart agriculture concept is a very, very busy and a very, very high exciting topic, right? So also in the Japan, this is AI technologies and the smart agriculture is a very, very, so many researchers try to apply not only the agriculture or the food or the forest industries. Oh, this is one typical application in the such as AI technologies. This is a collaboration in the KMIT. It's one of the university in the Thailand. Rapid and non-destructive detection is the Thai jasmine rice. In this case, we try to measure in the so many kinds of the Thailand rices, in the brown rice and the milled rice. And by analyzing in the NIR spectra on some try to the application, some of the data science technologies, and the finally, let me see. Yeah. Sorry, the very, very small size of the word. In the finally, brown rice and middle rice is a very, very easily classified in the high accuracy percentage of the 84% or the 95%. Oh, you know, the shape of the rice is very, very variable. So basically, it's not so easy to classify in the brown rice and the middle rice. However, with the aid of the AI technologies and or the data science technologies, on the basis of the NIR imaging, we can easily to classify in the two types in the rice. So not only the AI technologies, we try to apply for the fluorescence. So this means the very, very unique research concept, elucidation the fruit softening mechanism in the development of the freshness monitoring technologies. In this case, we by this measurement system, in the very, very short pulse laser is irradiated in the kiwi fruits. And after able to perform the transmission measurement of the kiwi fruits, strong pulse laser light in the 846 in the NIR lasers, we discovered the strong correlations between the fruit hardness and light scattering coefficient, and much larger than the absorption coefficient. It is very, very clarified. And this is the last slide in the monitoring of the fruit freshness using fluorescence lifetimes of the strawberry. In this case, we detected the reflected fluorescence light, and in any way, we can very easy to evaluate it in the freshness of the strawberry by the fluorescence NIR light. It's one of the future trend of the NIR applications, I think so. So, for today's my presentations, I try to inform as much as possible in the variabilities of the NIR spectroscopies, especially in the area of the food or the agriculture, and partially in the forest science. Maybe the origin is coming from the sunlight, and we know in the concept in the visible light and the partially UV light, X-ray, and additionally, is among in the infrared light, visible light. Yes, this is NIR light is much more powerful to analyze in the chemical component of the fruits or the agricultural product or the food items. So, such a series of experimental research was done by my research group, and fortunately, my research group is including so many international students from the China, Indonesia, Thailand, Philippines, and in the future, I hope in some of the Indian research students also can join my research group. And I'd like to intense two guys. Two guys is our research. My young colleague in the Dr. Tetsuya Inagaki, Dr. Tema. Without the big effort, I cannot do such a very, very widely spread it in the NIR research. This is the final slide. Thanks so much for the kindly listening to my presentation. Thank you.
Okay, thank you, Professor Tsuchikawa, for such an absorbing lecture. We are really thrilled to listen to you. And you see the enthusiasm among the Indian scientists and students and professors here. There were more than 70. They were there throughout the session. So it was really enlightening. You started with agriculture, forestry, mentioned something a little bit about medical science, and everyone knows your expertise in the field of wood. You have done excellent work and published many papers on wood with NIR. And now we are really very glad to see that you are also exploring the new areas of technology like artificial intelligence and convolution neural network, hyperspectral imaging, as well as fluorescence technology. So I think we can take one or two questions physically, because I think you must be tired because you're talking for nearly an hour. So
thanks so much.
there are many scientists. So there are many scientists here. So we can take one or two questions. I think Professor Somir Pal is with us. Is a very, scientist at in our center here. Professor Pal, I think you have many questions, but you can note down the questions.
But I can ask one or two if time permits.
Yeah, please.
Yeah, Professor Tsuchikawa, can you hear me?
Yeah. Sure.
Okay. Oh, thank you very much for your enlightening talk. Let me congratulate you regarding that.
Thanks so much.
My first question is, how successful in the food industry to detect the sugar by using NIR? Is it really successful?
Yeah. Thanks so much. Is very, very basic questions. In my knowledge, I told to you in the sugarcane factories, it's a very, very successfully to check in the online monitoring in the sugar content. And not only in the sugarcane content, in the case of the so many kinds of the food factories, it's one of the important factor is to the key is the sugar content. It's very, very easy to monitoring by the NIR spectra. Though maybe so far, so many food factory in the Japan already introduced these devices.
Right. Now, why I am asking? Because of the two factors.
Mhm.
One factor, like in a sugarcane factory, you have shown a picture that sugarcane were cut.
Yes.
It is chopped and tested. But whenever you test the sugar, whenever sugarcane is cut, and whenever sugarcane is intact, it is a completely different sugar, because the glucosidase, that is the enzyme, will act on it and will try to do the change the nature of the sugar. So NIR spectrum, if you want to catch it with a 1940 nanometer versus 1420 nanometer, it will be completely different. I don't know which wavelength that you are using.
Actually, I'm not so as familiar with such as very, very strict difference of the absorption band in the sugar. However, how to say, in the case of the sugar cane, of course, by the chopping in the some of the chemical reaction was happened. However, the much more the important point is to set up in the very, very good regulations for the to process, to check, and to measure the NIR devices. Much more important point is if such as a protocol is introduced in so some of the sugarcane factories, and they try to chop and the measure and the packing in the different analysis, different methodologies. Of course, the data was not so good.
Right.
However, in the area, in my knowledge, in the Okinawa Island, they set up, they ordered in the same chopping time and the same knife and the same devices, same cup, and they can keep in the same qualities by using NIR.
That's very interesting, because if you chop, then simple polarimetry will tell you the sugar content. You do not need the NIR at all. But the change is like whenever you have a food product intact and you are penetrating from the top and you are penetrating chlorophyll and phthalocyanine and trying to get the sugar, that is the challenging. Because cutting apple and checking sugar is not a problem. You can get it. But getting sugar content in the top of phthalocyanine and chlorophyll is really challenge. And most of industry fails, because I am doing consultancy and some of the companies are with my handholding. They are always complaining, sir, whatever you are predicting with the hyperspectral stuff is not doing like that. So because of that interference. So this is my first comment. My second comment, like whenever you are doing the picosecond dissolved, your fruit detection, and you just go for retroreflective, what is the measurement parameter? You are measuring fluorescence or you are measuring scattering? Freshness of that fruit.
Thanks so much. It's a very, very basically it's a very, very good point for the last my slide. And I show you the two slides. One slide in the transmittance right of the kiwi fruits. In this case, we pay attention to the variable of the scattering coefficient and absorption coefficient. Maybe you know very well, in the fruits of some of the chemical component item, agricultural product, it's comparing in the scattering coefficient is the huge values compared to the absorption coefficient. So this means NIR is very, very widely spread in the material. Or in the case of the kiwi fruit of something, we try to in the very, very precisely in the changing in the scattering coefficient of the absorption band. And in the case of the reflected light, in the case of our target in the strawberry, in this case, we only pay attention to the lifetime of the fluorescence. Maybe you know, in the fluorescence is one of the factor in the healthy condition is the fruits. So in this case, we try to in the how is the lifetime of the fluorescent light is changing of the depends on the how to say the healthy condition in the strawberry.
Yes. So you were talking about the autofluorescence. That's it.
Mm-hmm.
Okay. Thank you very much. It's very
so much.
exciting talk.
Thanks so much. Thanks so much.
Okay, thank you, Professor Pal. Any other questions? Dr. I can see Dr. Bandhavata is there.
Another Bandhavata?
Yeah, Amitabh Bandhavata is there.
Hello, sir.
Aha. Hi, nice to meet you.
Nice.
Yeah, Dilip.
The why is not, it's not a technical question, just I want to a non-technical question regarding your last slide. So what is the opportunity of PhD and postdoc in your lab? Is there any current opening or something like that? Because there's so many there.
You mean the possibility of the postdoc, right?
Postdoc or yes.
Yeah. Yeah. Of course, it's very, very welcome to invite the brilliant in the person as a postdoc. It's of course, it's not only the India or the Japan. It depends on the financial conditions. Oh, in case of the Japan Council of the universities, the professors is strongly recommend for all the overseas students as firstly to apply for some of the Japanese government in the supporting of the financial situation. So if you are so interested in to get the financial support from the Japanese government, I will inform you some of the information in the how to apply. However, it is not so easy.
Yeah, it takes
Okay,
time.
thank you. Thank you.
Okay. But anyway, if you are so interesting, we should try to discuss much more.
Thank you, sir.
Okay. Thank you, Dilip. I can see Dr. Samuel, right? You have any questions? Dr. Rai?
Yeah, yes, please. Namaskar.
Namaskar.
Yeah, namaskar.
No, we don't have any question. We are
Okay.
here.
Okay. But you must have seen the NIR spectrometer on the bark of a tree. So I was thinking that since you are in the Syncona for estimating quinine, so if that type of device can be used directly in the forest, that would be of great help to you.
No, actually, that we have discussed earlier,
Yeah.
and we are depending completely on you, sir.
No. Okay.
Like whatever we discussed, using a simple NIR machine, taking it to the field, and from there only if we can get the report.
Yes.
Something like that.
Yes.
I really don't know whether it is possible or not.
Yes, we can make it, no problem. But you have question, ask question. But if you need any instrument, we can make it. We are making instrument.
Okay, thank you, Dr. Rai.
Thank you.
We have also Dr. Devdutt Misra from Fasai. Are you here?
I'm here.
Okay. You have any questions?
Yeah, good afternoon, everyone. Actually, it is
Yeah.
wonderful to see so many learned person in the same place. And from FSSA, actually, we are more confined to the regulation, as sir was telling about. The question was about this sugarcane, and the discussion was about having a proper regulation to check the way that we get the actual sugar content. So you sir spoke about this artificial intelligence, and I have heard a lot from you about the machine learning. Like you need to do a lot of samples to check that the traditional method that we adopt in the laboratory is actually giving the same result when you apply the NIR spectroscopy. So I just wanted to know what is happening in Japan, like whether the NIR is actually replacing the common equipments that are used in the food laboratories. Is that the current scenario, or it is yet to be adopted? That I was wondering. How is the scenario in Japan? Because in India, we are really discussing a lot about how to do this rapid analysis. Like what you have shown in your slides is so interesting that if we can check the quality and safety aspects of the food right in the factory, then we don't need the labs to be so actively doing the surveillance and the regular testing. If it can be tested itself at the factory or maybe at the field level. So in India, we are still little bit skeptical how to adopt these rapid technologies. It would be really wonderful if you can do it. So just I wanted to know how is the scenario in Japan? Is it already replacing the equipments, like we have big equipments like LCM, SMS, where we need a lot of things to be available, like proper environment, AC, everything is supposed to be perfect, then only we can run such equipment. So if NIR can replace them, it would be wonderful. I just wanted to know what is the scenario in Japan?
Yeah, it's a very, very, how to say, it's a big problem also in Japan. Now, you know, NIR spectroscopy is so complicated and including so many information spectroscopies. This means very, how to say, is very easy to trial for the matching of the some of the chemometrics of the statistical analysis. And now is that in the AI or the machine learning, CNN is also the very, very, very busy and very high topic. And actually, I read so many papers informed in the high utility situations of the NIR with the aid of the AI technologies. But, it's like the one of the black box. Though some researchers actually don't like to introduce these technologies. Of course, in the case of the online or some of the factories, they understand by the combinations of the NIR and the AI can give us very, very good predictions. However, some of the engineers is strongly suspected is what is the background of the why such as the data could be evaluated, but very difficult to easy to simply give us an answer. So in my opinions, maybe not only the NIR data or the another spectral data in the how to say, in the combinations, in the spectral researchers, in the some of the statistical researchers try to collaborate much more. What is the best way to analyze, to utilize in the such as the AI technologies? Maybe situation is the same as India, right?
Yes, that's what we are also facing here in India, because we have to be very sure that the results we get in NIR spectroscopy is exactly what is expected.
Yeah, thank you.
Thank you.
Yeah, Dr. Mishra is from food safety organization, and they are the regulators. They check the quality of all the food items and all that. So they need this type of machines badly, so that because they have to handle so many samples per day, food samples, spice samples, and all these things. So we hope that with your research and the new companies, they are also making so many products, it will come. So any other question?
One more question, if I can ask.
Mr. Fukun is there.
Yeah, can I ask Mr. Professor Bondapani?
Okay. Let me complete. Dr. Mishra has another question. So
Yeah.
After that, I'll request you, Mr. Fukun. Yeah, Mr. Mishra, you please.
I was just curious to know whether it is possible to check microplastics in water using a NIR technology, because microplastics, as we know, is becoming a big burden in our ecosystem. Is there any possibility, because FTIR people are using with a microscope? FTIR is still used, but NIR, whether it is possible?
Yeah, in my knowledge, I have not never seen in the application in the NIR in the microplastics. In the case of the microplastics, it's a big point by using the right of the spectroscopy is how is the scattering situations, because in the scattering is depend on the size of the particle and the density of the particle, and maybe in the NIR, right, it's not so sensitive to the particle side or something. Of course, it depends on the densities, but as told to you, in the FTIR is much more sensitivity maybe. But anyway, it's a good suggestion from you. I try to survey how is the possibilities is NIR to the microplastics. Thanks so much.
Thank you.
Okay, thank you, Dr. Mishra. I think Mr. Fukun is waiting here.
Yeah.
Mr. Fukun, if you can comment here.
Good evening, Professor Tsuchikawa. My name is Joydeep Phukan. I work as the secretary of the Tea Research Association, Toklaya, actually. See, so I'm based in Calcutta. So I just wanted to ask you one thing: is that what I could hear from my colleagues, Dr. Ajanta Hazarika and his team, regarding, you all can detect the tea quality through the polyphenol through NIR, actually. See, I think that is possible. But on a other subject, like can NIR be used for detection of maybe contaminants or pesticides? That also can be this thing, because that's a foreign element which is there if it's there in the tea. So if you can detect polyphenol, can you detect maybe other compounds also, like say if its pesticide is there, or maybe other contaminants which are there in tea?
Yeah, thank you so much. It's a very, very useful and the important questions concerning the application of the NIR. Not only the tea or some of the chemical component, some researchers asked for me how much percentage could be detected by the NIR. In case, for instance, in the polyphenol, other than contaminations, whether NIR could be detected or not, it depends on the amount of the component. Or in my knowledge, for instance, in the several ppm order components, it's a very, very difficult. However, several hundred ppm order or the several thousand ppm order chemical component could be detected by the NIR, because it's so many information in the chemical. However, basically, in the signal, NIR signal is very, very weak. So how such as the signal of weak signal could be detected is depend on the quality of the sensor. If you try to apply the very, very high quality sensor and it has a very, very high signal to noise ratio, maybe several hundred ppm order chemical component could be detected is available by the NIR. So now I'm not sure how much component is including in the polyphenol or something, but I guess it's not so the high density or the very, very low density, right? In the tea.
Very, very low.
Very low.
Very low, because European Union will not take the tea even if it is stressed in ppm. So you need to have a LOD, limit of detection, to be less than ppm. That is the ppb.
Oh, super difficult.
No, but basically there's one more. One is for exports. The other is basically some use of. There are a lot of things which is happening now is that the use of unapproved chemicals. So like there you need to just see if those chemicals are there or not. So it's like if it's there, then these are not to be. It's a no-go scenario. But if it's not there, then you can pass off. So like maybe if you can have a band of 5 chemicals or 10 chemicals, wherein we say that like if it's only detected, then you can't touch those teas actually. So that's what actually for exports I'm saying it's a different thing, because actually I think Dr. Mishra is there from FSSI. We had the food safety, we had 2-3 meetings. So we are trying to find out a very easy method of detection of unapproved chemicals which are being used in tea. So so it's like if it's a quick detection, it can be done, then it's much easier for the industry actually.
Okay. Anyway, it's a very, very, how to say, it's a challenging area to hold the application of the NIR. Okay, thank you.
May I add, Dr. Bandyopadhyay?
Yeah, please.
You see, some of these things, these pesticides, majority of these pesticides have very clear fluorescence bands. So many of these problems can be solved by fluorescence spectrometry. And they are very precise, and because it is based on UV light, its penetration is far better. And you get very precise, very small quantities also, in ppb quantities also you can detect it. So pesticides, I think fluorescence will be a better thing than NIR. UV-based fluorescence.
Yeah. And now is I only want to introduce is the applicability and the possibilities of the NIR spectroscopies. And basically, to get the much more lower component is very easily by using the fluorescence, right? And how to say, anyway, comparing in the another magnetic wavelength range is NIR so far is a little bit a mysterious area. So some researchers try to find is much more the good possibilities and applicabilities. And one of the possibilities to use the fluorescence. However, I also agreed towards from the viewpoint is much more to getting the precise situations in the fluorescent light is much more better. Though every time we try to continuously to comparing in
remote sensing also for plants, they are trying to use hyperspectral UV and fluorescence. They are getting much. Suppose, say for example, by using hyperspectral NIR, detecting water content in plants becomes very difficult. But with fluorescence, it is much easier. So a good amount of work is now shifting towards fluorescence, remote sensing.
You mean the application of the remote sensing, right?
Yeah.
So,
so remote sensing detection of water content in plants is much more difficult because NIR absorbance and all these things, those difficulties are there. Chlorophyll, easily you can detect, but not water. But with fluorescence, you get a much better result.
And to check all the moisture content, it is very easy to apply an NIR area because it's how to say, there are so much more the important absorption band. And it depends on what is the target is to check of the chemical component. And I know in the remote sensing, fluorescence, and some researchers try to apply in the partially in the visible light and much more the near infrared light.
Yeah.
And anyway, we try to what wavelength area much more the better, and some kind of the application situations. I think so.
And some of the new things which are being used now is radiative transfer. Radiative transfer is being used at least for remote sensing more and more, because there you get much more clearer and with logical answers. It is easier to explain radiative transfer functions than NIR functions. In terms of the black box, radiative transfer is less black box system than NIR.
And much more another point I like to intense is from the viewpoint of the applications in the quality and the price, and how is it easy to design.
Definitely. Definitely. Thank you.
Thanks so much.
And in summary, actually, there are so many technologies. We have this NIR, we have this fluorescence, hyperspectral, and this Raman spectroscopy. So different technologies have different areas of application, and definitely there's no doubt about it that NIR can also be used for some applications. But at the same time, we must remember that NIR cannot solve all the problems. And so if you look into the other technologies also, they cannot independently solve all the problems. So maybe I don't know whether what is the opinion of Professor Tsuchikawa. I was thinking that if you can have different types of spectrometers in one package, so for all sorts of application, we can have a single instrument with different technologies. That might be the future.
And additionally, for instance, in my laboratory now, as our another target is the application of terahertz spectroscopies. So terahertz is a very, very new area, but maybe what is much about the advantage point to utilize in the terahertz spectroscopies from the another magnetic wavelengths area. However, by using the terahertz spectroscopies, we can very successfully to check investigate in the fine structure, in the crystallinities of the chemical component. It's another advantage of the terahertz spectroscopy. But today my topic is only dedicated to NIR. And if I have another occasions, I try to do much more.
Okay. No, you have a wide experience in different technologies. So that's why our scientists here and professors, they're interested to know as much as possible from you. But I don't think in a short time it's possible. But anyway, I think we had a very nice discussion. Any other short question? One question I can expect from still I can see more than 60 scientists and students are there. Shantanu is there or
yes, sir. Good evening, everybody. So the presentation was a very excellent and informative. I hope actually we will do some more progress in the NIR. And at this moment, I do not have anything to speak or comment on this. Okay, thank you.
Oh,
Thanks so much.
Okay.
Thanks so much.
Okay. So what I think, I think let us conclude now. We have almost 1.5 hours. We have Professor Tsuchikawa is with us. We are really very happy with, and it's really, I must just say that it's a very successful kickoff webinar today, and we hope to organize these webinars throughout this year to sensitize people with not only with NIR technology but with other technologies as well. And we hope that we'll have a very successful conference next year in the month of December. So with that, we express our sincere gratitude to Professor Tsuchikawa and all others who are present in this audience. We have many scientists and professors here. So thank you very much for making this webinar a great success. Thank you very much. We'll wait for the next announcement for the next webinar.
Thank you for the organization.
Thanks so much.
Okay. Namaskar. Thank you all, Professor Tsuchikawa and others.